Hi.
Hi, welcome to Live Coding a Game in 45 minutes with open source tech. Next slide. So hello, I'm Tim.
I'm Paris. You can tweet at us at the handles on the screen. We love to talk to you.
And we should be responding live because this is the future.
We're mostly friendly.
So we're here to talk about games. So we work on games. This is a game we've worked on. Actually, we didn't do a huge amount on that one, but we did help a little bit. We also write a lot of books. We write a lot of books around all sorts of different things. We've got a bit of a bent towards mobile development and games.
Yeah.
So today we're going to be talking about Godot, the open source game engine. Now, the most important bit is this next bit right here. How do you pronounce Godot? Now, we're going to be pronouncing it Godot, like Godot, not Godot like Godot. You can pronounce it however you want. No one's going to mind. We're pronouncing it this way because this is how Patrick Stewart pronounced it.
We're not actually sure which one's the official pronunciation, but we're Australians and we're fans of Patrick Stewart and Ian McKellen, so we're going to go with Godot.
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 You pronounce it however you want. All right, so that's the hard bit out of the way. All right, so Godot is a fully open source game engine, game development tool, whatever sort of term you want to use. It's part of the Software Freedom Conservancy group. It's one of those sort of projects. And now what we're going to do is Paris is going to jump into Godot, and I'm going to talk a little bit about game engines just as an abstract sort of concept. So if you're not used to game development, and depending on your background, you've probably never done it, the old school way of doing games was you would basically just sit down and start coding up the game. You would do everything in code, other than obviously artwork and audio and that sort of stuff. But it would all be built entirely, done in code effectively. You'd be building out the whole sort of tool set yourself. That sort of changed when this concept of engines came about, which was basically taking reusable bits of the code and then being able to reuse them. Over time, the engines got more and more flexible, and they sort of became their own almost spin-off projects to the games themselves. Godot is one of them.
So, we're going to jump into Godot and we'll talk about how to build an actual video game. So, Tim's going to kind of narrate what I'm doing. I'm using a computer, so apologies if I'm not looking directly at you at all times. There is a computer below. Trust us on that. So I've fired up Godot here. Godot looks like this. You can see its icon down in my dock. Godot runs on Linux, macOS, Windows, and probably anything else you could name because it's actually written in Godot. So,
that's a very common thing. You'll see a lot in game engines, both the open source and the proprietary ones. They're generally written in their own libraries, which has some advantages and some disadvantages.
I've fired up Godot here, and I'm going to click the new project button, and we're going to make a project live in front of you in the next 40 minutes or so, hopefully. So I'm going to click the new project button, and we're going to call our new project Paris and Tim's Game.
I love that game.
And we're going to put it on my desktop, because that's where all projects should go.
All work should go on your desktop at all times. That's professional development tip number one.
So I'm going to click the Create and Edit button, and Godot's going to create a new project for us, and then relaunch itself, because that's what it does.
Now, this is, depending, again, on your background in sort of game development, pretty much every game development tool now sort of starts with this sort of like empty void with a grid on it.
It's like Tron. Have you ever seen Tron? This is the grid. The digital frontier.
Is that what the line is? I can't remember.
Something like that.
We don't have Bruce Boxleitner, so.
We do not.
That would be great if we did, though. Oh.
It would be great.
We can't afford it.
No, we can't.
So they're now actually built up in these sort of virtual 3D environments. You build the world you want to create. You then drag in the gameplay elements themselves. You'll have to actually code them, which Paris will do in a moment. But you've got sort of this open world that you can do things in. You no longer start with code. You start with the world and add the code into it.
So we're going to make a quick little 3D game in Godot for you today. So I've got this empty scene here. It's completely empty. It's not even saved. You can see it says empty right here. And I'm going to add a thing to our scene. So this inspector here shows us our scene in Godot. A scene is what's comprised in a specific view. Godot is made up of scenes. You compose your game of scenes. Scenes have nodes in them. So this scene currently has nothing in it. So I'm going to add a node, right, to our unnamed seed. So I'm going to click the little plus button here, and it will come up with this box, which lets me pick a type of node. I'm going to pick a spatial node. So if I click spatial, it'll tell me what it is.
So Godot actually has a whole bunch of sort of out-of-the-box convenience nodes, which do all sorts of things. A spatial node is just one that basically exists in space.
So we now have a spatial node in this scene. Our spatial node doesn't have much more than a transform, which is a position in 3D space. You can see it there. It's got no visual elements, though.
It's got an X, a Y, a Z, a Z, sorry, an X, a Y, and a Z.
It's Z, Tim.
Z, and it'll have a rotation and a scale.
Anyway, it's in our scene now. We've got it here. It's right here. A spatial node is the parent of all 3D things in Godot. So I'm going to click the plus again while I have this spatial node selected and add another node. That node is going to be a mesh instance. this thing.
So a mesh instance is another sort. It's like a subclass basically. This allows you to have meshes, which is the game term for models.
One helpful thing about Godot's node adding UI is it actually shows you the framework, the relationship between things. So if you see node is the top of all things, below that is spatial, and then we can go down, we can find our mesh. But if I just filter, so if I type mesh, you'll see that mesh instance descends from node.
And so on and so forth.
And a bunch of other things.
Yeah, a mesh is basically just something that will hold a 3D model in it.
So now I have a mesh instance as a child to my spatial node. I'm going to add a cube to this scene. So over here in the inspector for the currently selected node, which is mesh instance, so over on the right side of the screen, in the top right, I'm going to add a mesh. Godot comes with a bunch of primitive meshes. We want a cube. So I'm going to click that cube.
You can also import, 3D meshes made in Blender or that sort of stuff.
For speed reasons today, we're going to try and do everything within the engine.
Because otherwise it'd just be boring jumping back to Blender, going saving the file, dumping it out.
So I've added this lovely cube mesh, and I'm going to go. It's amazing.
It's such a great cube.
It's amazing. I'm going to go over here to material, and I'm going to add a new spatial material. A spatial material is just a thing that can give something a color. Tim's going to tell me what color to make this though, because I am very colorblind. So we're going to set its albedo to a specific color.
Ooh, let's go. Let's sort of go with an orangey one. So you got sort of
orangey,
the right there. Yeah.
Looks something like this.
Yeah, we'll go with that. This is more yellow.
This is going to be our floor. So our floor is going to be orange. Okay. So I'm very colorblind. So Tim is going to pick the colors for me. That's our professional relationship. Tim picks the colors, and I make the cubes.
I go.
So we have this nice orange cube here, which is descending from our spatial mesh. That's really, really good. So now I'm going to select the mesh instance over here in the scene inspector, and I'm going to click the little mesh button up here. Okay. So this button will allow me to create a tri-mesh static body. This is a thing that will allow collisions to occur. So currently this cube does not exist in any sort of physical sense. It's just a picture of a cube. But by giving it a tri-mesh static body, we're going to say this thing has a body. It exists within the physics engine that Godot ships with.
This is an interesting sort of side effect, I guess, or quirk of modern meshes being really high resolution. So in very, very early games, very early 3D games, you could actually just use the mesh itself as the collider. But now in modern games, and they got like, a gazillion little triangles, if you use the mesh as the collision system, it would just be too slow. So instead you add sort of an additional collision object around it to help bound it. You don't have to do that, because we're doing it with cubes, we could probably get away with it, but Godot is sort of working on the assumption you're making one of these, nice, lovely, pretty things, so you need to add a collider.
You'll see over here that our static body and collision shape have been added. A static body just means it's not going to move. So a static body is something that exists in the physics engine, can be collided with, but is unlikely or strongly discouraged from moving.
It's a literal unstoppable, immovable object, not unstoppable.
We'll get back to things that can move later on, hopefully. So I'm going to select the mesh instance again. I'm going to push the R button, which switches to the scaling tool. You'll see when I push the R button, the scaling tool became active up here. So you can see all the different tools we can pick, but the R button is the scaling tool. And now I'm going to squish this cube a little bit to make it into a floor. Okay, so all this is doing is just changing its parameters. Actually, I'm finding that's not very precise, so instead of squishing it, I'm going to go over here in the right side and use the transform inspector to change its scale to something. So I'm going to say it's about 10 on the X, nice and long. It's about 0.5 high, and maybe 10 on the other one. So it's a nice big flat floor.
So what Paris is doing over in the inspector there is he's modifying the transform values. This is sort of an approach taken by, I believe, every game development tool out there now, both the proprietary and the open source ones, in that they have this sort of like component flow model is sort of how I've seen it described. Basically, you give components and attributes to these nodes in this case, and then they control how it actually works. So there's sort of like this clear separation between here's the thing in space and here's the properties it has on it.
Absolutely.
It's very, very common. It's not just a Godot thing.
So I've just renamed that spatial node to floor, just because it's a floor. You do that by clicking and pushing enter, or you can right click on it and go rename. And that's everything for our floor. But you'll see it's still an unsaved scene. So I'm going to push Command S on my Mac, Control S on Windows and Linux, and I'm going to save it. Floor.tsen is a fine name for that, so I'm just going to leave that, and I click save. So now you'll see our floor scene has been saved. It is also in the file system inspector down here as a file that we can actually move around and do stuff with. That's everything for the floor.
So something that's kind of interesting about Godot And it's something that other game engines have started taking, and I think they've been very inspired by Godot, is Godot sort of builds everything up out of these scenes, and you're designed to import and nest scenes. So you might have something else that the floor will have in it. You might have a player, and then you'll have sub-players.
And you'll see that in a minute.
You build a lot of these sort of like these nested scene objects, and then import them into other scenes and so on and so forth. And at the time, that was sort of, now it's very common. You'll see it everywhere, but Godot was, I believe, the one who really pioneered that.
I think so.
As the idea of like, go nest mad.
So I'm going to make a new scene now and speed things along a bit so we can actually see what's going on. So I'm going to click new scene, and you'll see a new empty scene. My floor still exists up here.
Back on the grid.
In my new scene, I'm going to do the whole process I did last time, which is create a nice spatial node. Inside that spatial node, I'm going to add a mesh instance. It's pretty much exactly the same as I did last time. Inside that mesh instance, my mesh this time will again be a cube, and Tim's going to pick a nice new color for me to set the material to when I create the material. So my color will be,
I'm thinking
what is it, Tim?
we should go like a yellow.
These are the walls. You want a yellow wall like this?
Ooh, that's more green.
You don't like my yellow.
Let's drive it up a little bit.
That's too green.
Yeah, that'll do.
It's
Why
disgusting,
not?
but
yeah, that's
sure.
awful. But they're walls. Who looks at walls anyway?
With that mesh, I'm going to create another tri-mesh static body because the walls don't need to move. And then I'm going to scale the wall. So I'm going to do the transform over here, and I'm going to say maybe the wall should be 0.25 or 1 and 10. So it's a nice long wall.
Wow, it's miraculous. You're just picking the exact right numbers for this.
It is amazing, yes.
Totally didn't
pre-prepare this, yes. I'm going to rename spatial node over here to walls, and then I'm going to save the scene. Walls. That's great. Now we have two elements. That's actually amazing. So that's our two scenes so far, wall and floors, and they're both saved in the file system. So I'm going to create another new scene now, and in this scene, I am going to add a spatial node, surprising absolutely nobody.
I mean, you surprised me.
Sure, yeah. I'm going to rename that spatial node now to environment, because this is the scene that's going to hold our level. This is going to be the world that our player exists in and has their adventures in. And then I'm going to select that spatial node that I just created and click this link icon instead of the plus icon. So the plus icon lets me add new, fresh nodes to this scene. The link icon lets me bring in existing scenes. Then I click this link icon, and you'll see it knows that there's two saved scenes in my project, right? So I'm going to add the floor. Bam. And this is linked to that other scene. So if I went and edited this floor, it would take effect in this scene now because it's just bringing an instance of that floor in for me. I'm also going to add the wall. So I'm going to select environment again before I add the wall, just because I want the wall to be a child of the environment, not a child of the floor. I'm going to add a wall. Okay, that's amazing.
Oh, I love it.
I love it. I'm going to move that wall around using this tool here, the move mode. So I'm going to push W on my keyboard, and you'll see these arrows change into arrows, and I can move it around. Now that moving around isn't quite as, snappy as I want it to be, so I'm going to click this button up here, which is enabling snap mode, and we'll make it snap as I move it.
You can also configure the snap grid if you want. We're just going to use the default.
I'm going to click top view so I can see where I am. So this thing up here lets me move different views. Top view means I can just position things a bit more effectively. So got a nice thing there. I'm going to click, while I've got this wall selected, I'm going to push Command D on my Mac, Control D on Windows, and duplicate it. And I'll have another one in exactly the same position. I'm going to move to the other side because I want to have walls on both sides.
Now, if you're not sort of used to moving around in 3D space, this might be a little bit like, well, hang on, what's going on? But this is definitely the way you do it in games now. You're going to be spending a lot of time moving things around in 3D space because it does actually work out faster to do it this way.
So I've duplicated the wall 3 times here. I've got another one in the middle. This one I need to rotate to go up on the sides. So with this wall selected, I'm going to go into its transform inspector over here, and I'm going to rotate it 90 degrees, minus 90 degrees on the Y. So it's flipped the other way. I'm going to put it up here, and then I'm going to duplicate it again and put it down here. Look at that, isn't that amazing?
Oh, I love it.
I could fiddle with the snapping, but I'm lazy, so I won't. But you can go and click here in the transform and configure the snap, so you can make it, more precise. So I could actually do it because I'm not as lazy as I thought I was. But I can, click this thing and then I can move it around. So it's different snap distance. But we don't need to do that. It looked pretty good how it was. So I'm going to save that as environment. So now we have this nice saved scene. Beautiful. Look at that.
Oh, I love it.
It's stunning.
Should we go to the perspective view?
It's stunning.
Oh, look at that. Oh.
So there's a couple of things wrong here. I need to move these walls up a little bit, so I'm just going to grab them and slide them up a little bit because they're not quite in the position that I want them to be. So I'm going to grab that one, and then I'm going to grab that one and move it up a little bit, and I'm going to grab that one and move it up a little bit, and I'm going to grab that one and move it up a little bit. So now they're all kind of more wallish.
Love it.
Beautiful. Okay, so I'm going to push Command S just to make sure that's saved. That's amazing. So have this beautiful floor. It's great.
We're done.
We're done. That's the entire game. No, it's not. Okay. So what I'm going to do is I'm going to rename this floor to lower floor.
Because we're going to be adding an upper floor.
I can put spaces in. I'm just an old school Unix beard at heart, and I don't believe in spaces. I'm going to link another instance of the environment scene. No, I'm not. Sorry, that was a mistake. I'm going to link another instance of the floor scene.
You can't nest yourself
yes.
Because
sorry, I was overthinking. So now I have two floors on top of each other. I'm going to move this one up and move it away and put it over here somewhere for now. That's pretty good.
Yeah, it looks
that's fine. I'm going to rename that to upper floor. I'm not going to put any walls on that one because I like to live dangerously.
Yeah. Death Star, guide to building.
Yeah, it's the Star Wars approach to building things. Where you don't actually want to make sure there's any safety features at all.
You want your employees to fall clean off the ramp, into the big green beam.
So now that we have our two floors, one with walls, one without, we probably want a way to get from one floor to the other floor. So I'm going to make a new scene again.
It's the first thing they teach you in game dev.
Crazy.
Make sure there's a way to get from one floor to another. It's actually not the first thing they teach you.
New spatial node called ramp. Okay.
So just pointing out, we didn't have to do these as sort of like individual scenes. It's just sort of, it's the more Godot way to do them as individual scenes. That way you can sort of keep moving them around as needed, making changes in one and not having.
I was getting slightly ahead of myself here, but what I need to do is I've made a new spatial node with a mesh instance, and in that mesh instance I'm adding another cube. Tim's going to pick a colour for me again.
Well, I mean, we're sticking with the greeny-yellow palette, so I guess we're going to go with that again.
Yeah, what colour do you reckon?
Let's sort of... there? Yeah, there.
That looks like that screams ramp to you?
Yeah, that
screams ramp.
Got big ramp energy.
Big ramp energy. Okay, we're clicking this mesh instance, we're adding our nice static collider again, and now we're going to scale this mesh. I'm going to use the inspector to scale it again just because I'm lazy, and with these totally not pre-prepared numbers, I'm going to go 1.44, or 0.1, and the very precise 5.47. That looks like a ramp to me.
Yeah, it looks fairly ramp. It almost looks like a mini golf sort of ramp.
It does. That was the idea, yeah. So I'm going to save that scene as ramp. Now we have that. Done. Amazing. Back in the environment.
Mind-blowing.
So over here, I'm going to go back into my environment tab, and I'm going to link in the ramp. So
let's add in a ramp.
Again, I'm going to click the environment root node instead of loading it on.
Are you saying we're going to ramp things up?
We're going to ramp things up. Thank you, Tim. Okay. We're going to link in the ramp. It's very interesting.
I so hope no one laughed. If you laughed, that's actually
tweet at us if you didn't laugh.
Yeah, that would actually be good.
Yeah, okay, so we've got the ramp in our scene now. That's pretty good. It's kind of facing the wrong way, but we'll get to that in a minute. Or I'll just move the floor the other side, depending on my mood. We'll see how that goes.
We control the universe.
We do control the universe. I'm going to rotate it just to show you rotation works. So you can see you get this nice rotating thing here. Looks like I can grab one of these. Probably that one, right? Yep.
Look at that.
Pretty cool. Then I'm going to move it over here. And then I'm going to rotate it a bit more. So I'm going to rotate it that way. So that's kind of,
very steep ramp.
Yeah, well, it's a hard world. Life is tough, Tim.
Life is tough.
Life is hard. Life is not full of joy.
Games are not at all for escapism now. Sorry.
So we've got a ramp. It's kind of connected the two platforms together. We're done, right? That's
Sweet.
It. That's it.
It's even better.
No, we need a player. So we actually need a way to play this game. So I'm going to make another new scene. Again, I'm breaking things up into scenes so you can see the componentized approach that Godot takes. I could have just made one scene and put all these objects into it. But then if I wanted to modify something, I would have had to undo it all.
The main advantage really becomes when you're building bigger games than just one sort of mini game like this, in that you can sort of actually create proper reusable components. Like you can have the player used everywhere instead of basically making a bespoke lovely player for each and every level. So the root node of my player scene is actually going to be not static because it needs to move. So it's going to be something called a kinematic body. Kinematic is just a fancy word for it moves. It participates in the physics engine.
But pretty much like all the other scenes, our kinematic body is the root node, but our next thing will be a mesh, because, it's a 3D game. Most things are meshes. Our mesh this time is not going to be a cube, it's actually going to be a capsule.
We're mixing it up.
As is tradition, the video game character for prototyping is a capsule. Tim's going to pick a nice colour for our player character here.
I'm thinking we go down into the blue palette because we haven't really spent much time there. Yep. That definitely screams player to me.
That screams player? Okay. Yep. We've got our nice blue thing here.
Let's rotate it upwards maybe?
No, we're not going to rotate upwards yet, Tim. Okay. We're going to rotate upwards later.
Okay.
I'm going to add a collision shape to this player though. So I'm going to go here and go collision shape. So we can pick collision polygon if it was 2D, but shape is 3D. So
Godot essentially has two engines that work the same. They've got a 2D and a 3D one. From your perspective, how you interface with them, they basically work the same. It's just, use the 3D forms of the nodes in the 3D one, use the 2D ones in the 2D form. The reason they're separate at all is just I'm assuming for performance. I don't actually know entirely
Pretty sure it's
why,
performance.
but
So
every game engine does it that way.
You'll see our collision shape is currently chucking in a little error there for us because it doesn't actually know what it needs to be the shape of. So what I'm going to do is I'm going to click this collision shape, and just like I did when I added a capsule on a cube, go over here to its inspector and say your shape is actually a capsule.
Ta-da!
And because I haven't modified the default parameters or rotated the capsule, it knows it's in exactly the same position, so it's good for now. So right now we have a player that can move because it's kinematic. It can collide with things because it has a collision shape, and it knows its shape, which is capsule. You could conceivably make your collision shape a different shape to the physical visual shape, which is something the video games do commonly because you don't want the player to squeeze into small spaces.
It's also very, very common in most video games, even if they have a super accurate player mesh. At least the initial crude physics system mesh will just be one of these like tic-tacs with the crude sort of capsule shape. Just for doing really quick and dirty checks, and then you can do a more precise check with the better high quality
So I'm
mesh
going to save this scene now. It's called player.
Also, it's traditional to use capsules for your temporary player models.
And I've also renamed my the root node to player. So the scene's called player and the root node is called player. That's it. We're going to go back into the environment now. I'm going to bring in the player. So I'm going to click the environment root, click the link button, click the player node. This should be familiar by now. And now our little tic-tac has appeared. Okay. We're going to transform him out of the ground, or him, it, whatever. I always call these things him. It's very, like, signifies the tech industry as a whole, really. We shouldn't be calling it him. It's a cube. It's a capsule. It's a thing.
If it does help, you will start falling in love with your terrible capsule children almost immediately. So
absolutely. So
you will start naming them.
I'm going to rotate it 90 degrees on the X so it comes out of the ground, and then I'm going to move it out of the ground manually. It doesn't really matter that it's floating above the ground right now, just because we're going to actually add gravity to the scene later, so the capsule is going to float slightly above the ground for now. That's absolutely fine. So that's done. Now I'm going to make yet another new scene after saving that one. So scene, new. This scene is very simple. It's going to be a rigid body. Okay. This is slightly different than the other ones because it needs to move around the scene in a different way. We'll explain that as we get to it. I'm going to add a mesh instance. I'm going to add a ball. Tim's going to pick me a colour for this ball.
I mean, balls should be red.
Balls should be red, okay.
Yeah, no, definitely.
Red.
Yep.
Done.
Oh, love it.
Love it. Okay, we're going to add a collision shape because we want this to be able to collide.
You can actually add proper textures to your models. You don't have to use just solid colours. It's just, for time constraints.
So we've added a collision shape in the shape of a sphere as well. So this ball is a rigid body, which means it can move around in the physics system using impulses. It has a mesh instance showing that it's a ball. It has a red texture on it, and it has a collision shape, which is also a sphere. I'm going to save that as ball.
I love it.
I'm going to rename the root to ball as well. Save it. We're done. Okay, that's everything we needed to do here. Back in the environment.
Link it back in.
You know where this is going. I'm going to click the environment and link the ball. Oh, amazing. I'm going to move this ball up to the upper platform.
The reason it's always sort of starting in the ground is because the center of these objects, when put at 0, 0, 0, is only half their height, so they're sort of halfway through the ground.
Trying to show you where I'm moving it to without confusing myself. So it's going to go over there. So now I'm going to go top view, and we're going to put it on here somewhere.
So Paris is using a trackpad. These tools are much easier with a mouse.
Yeah, so it's floating above there. As before, it doesn't really matter that it's floating because gravity will come into effect at some point. But right now, it's going to sit there. I'm going to make a goal now because we're going to make a little game where this little player, tic-tac, has to push this ball into a goal. That's what we're going to do.
Marvellous.
Marvellous. New scene, once again. Very simple. Making another spatial root node, so spatial. Nope, that's not. That's an audio stream player. I'm going to delete that and add a spatial node instead.
Yeah, we could have an audio stream
player. I'm going to rename my spatial node to goal, just because do that in advance. Very useful. Mesh instance, once again.
Are they called goals in America?
I don't know.
I actually don't know.
I have no idea. Okay, I'm going to add a cube. What colour is a goal, Tim?
Ooh, that's a good question. What colour is a goal?
Let's
have a look at our colours here. Let's go like a cyan.
What colour's cyan, Tim?
Oh, yeah, there. There, yep. Nice and bright. Yep.
Close? Good enough?
Yep, that's
cool.
Awful, but yep.
Okay, so I'm going to make a little bit of a collision body again. This is static again because it never needs to move, so we've got that. So we've got goal 1. I'm going to duplicate that. Actually, no, I'm not going to duplicate that yet. I'm going to scale it a little bit with my squishy thing here. So I'm going to smush it a little bit. Yeah, that seems fine. That seems fine. Going to make it nice and tall. Yeah, doesn't really matter. That's good. Going to duplicate that. Move it over here. So we're making bunch of goals, basically.
It's like goal posts,
the idea.
as it were.
That's probably good enough.
Yeah, I think so. That looks like a goal.
Yeah.
I mean, I could see someone kicking a football.
I'll save that as goal. Done.
I love it.
So once I go again, I go back into the environment. I'm going to import my goal. So I'm going to click environment, click the link button, bring in the goal. Amazing. We're going to move the goal into where it's meant to be. So that's probably over here somewhere because it's up on the big platform. That's where I want it to be.
Maybe back a little bit more?
Yeah, back a little bit more.
Yeah, it's a little easy.
I can never figure out how to move with the trackpad.
Accidentally bump into it and get
Okay, so the goals are over there. That's pretty good, I think.
I mean, they're goal posts.
Fabulous. That's amazing. So right now, I'm now going to make another little thing because it's a video game. Video games need pickups. I probably won't get time to actually make the pickup do anything, but traditional video games have a little pickup that you can, run over to make it have something happen. Going to make another new scene. Very simple. In this scene, I'm going to add an area. So an area is something that exists to be collided with or trigger something. Okay, so it's something that is just a general purpose thing that exists in 3D space and has some sort of volume, like not sound volume, like a volume you can exist inside. Doesn't
spatial volume.
Yeah, spatial volume. It doesn't actually have a thing inside. In this case, it will have a thing inside it because we want to see a cube, but the point of the area is to be a thing that exists for people to collide with. So I'm going to add another mesh instance, add a cube. What colour is the pickup, Tim? What colour is like the goal that you...
We already used red, didn't we? Let's have a look. Let's go... Do we have a dark purple? I don't think we do.
Dark, no.
Yeah, there. Yeah, let's go with that.
Okay, this is the colour of our...
That looks like a shield pickup, you know. You
yep,
pick
agree.
it up.
I'm going to add a collision shape to this, once again, because it's something that exists in the world. Needs to be collided with. It's going to also be cube-shaped. Where is cube? Box. There we go. Okay.
Sorry, box, not cube. Yeah.
Not cube. All right. Yeah. So sorry, I need to make that the child of that.
Oh, right. Yeah.
Yeah. Sorry. Okay. So we have our area ready to go. I'm going to rename that to pickup, just because that's what it is, and save it as pickup. Now I'm going to go back into the environment and add it to the
scene.
The scene. I'm going to click environment, link, go pickup, add it in. Going to move it over here and then pull it out of the ground a little bit.
I reckon.
Yeah, and put it in the corner.
We don't want people to find it immediately.
Yeah, it's just, this is the goal of our game, is to push the ball through the goal and to collect the pickup. It's a very complicated video game. It's going to sell millions and millions. So back in the environment here, we're going to add some code. So we haven't coded anything yet. You'll see I can run this. Godot will fire it up and then do absolutely nothing, because A, we don't have any code, and B, we do not have a camera to show you the scene. So we're going to add those two things now.
It is actually running though, right now.
Look, Paris and Tim's game right there.
I love it. Oh.
It's beautiful. We're going to go back into Godot and add a script. So, I'm going to click my player, which is here, this thing. Yep. Going to right click on it and go attach script. Amazing. And it's going to say what sort of script you want. It supports a bunch of different things. It also supports C# depending on the build you get. We're going to use GDScript, which is Godot's built-in scripting system. There's also a visual scripting system with nodes and also other things. We're going to use GDScript. It's very similar to Python.
It's sort of, yeah, Python-ish, I guess. Yeah. Inspired by Python.
Inspired by Python. And it's going to ask us what we'd like to call it. We're going to leave it as player.gd. GD is GDScript. I'm going to create, and it's got a built-in code editor. That's great. Fabulous. We don't need to touch much of what's there. We're just going to add some variables. So the first thing we're going to add is a move speed. So you declare variables with var. We're not here to teach you GDScript, so we're going to kind of gloss over how the coding is working, but if you've done any programming in a relatively modern language, it should be pretty obvious what's going on. So our var is called move speed. We're going to say it's, maybe 500. It seems like a good move speed to me. Programming is a lot about making numbers up. It's going to be a lot of that today.
There's a lot of game development where you find yourself just tweaking values, going like, this doesn't feel right. What if I double it? Oh, this is even worse. Okay, what if I halve it? Oh, this is great. What if I halve it again? Okay, that's no good. And then you sort of just like keep honing in on the specific imaginary number.
That's great fun
to do it. There's a lot of that.
So we have a move speed, which is just an integer. We have a direction, which is a vector 3. It's a 3-part vector. It's 3D space X, Y, and Z. So that's just our direction. Could be, a direction. We're going to do gravity. So gravity, just arbitrarily, making numbers up on the spot here. Obviously, no bearing on the real world. We're going to say gravity is minus 9.8.
Yeah, I wonder if that has any relationship to the real world.
Totally arbitrary. We're going to give a velocity as well. So velocity is important in 3D space. So velocity is what, vector 3 as well? Yep.
Yeah, well, it has to be.
It has to be. Yep.
'Cause
3D
it needs
space
to have a direction.
So I'm going to ignore this ready function. This ready function is called when a node is summoned into the scene by Godot.
This is your entry point into the code.
Yeah, but I'm going to actually implement a brand new function called physics process, which is a thing that's called every physics tick.
So Godot has predefined functions that you can use. They are underscored at the start, so you know them apart from the ones that you're using. We could go through all of them, but honestly, just look them up.
We want to
when
make
you
something
need
that
them.
works here and not explain the Godot. So we just want to get you excited about Godot rather than teach you Godot. So inside this function physics project, this is going to get called every time the physics tick happens with a delta, which is the time since the last tick.
Physics ticks are often slightly slower than frame rate.
So our direction is going to be reset to 0. That's good. And we're going to then check for some input. So if input is action pressed, which is going to check the action table in Godot. So we're going to check UI left, which is whatever key we've mapped to left. I'll show you where this is set in a second.
So Godot has a full input system. You can both set like imaginary keys, such as left, right, up, down, or you can set actual keys. You go like, no, I want to know that the E key itself was pressed.
So I'm just going to duplicate that 4 times, and I'm going to go UI right, UI up, and UI down. And I might have to come back and tweak these depending on which way I've oriented the scene, but for right now,
might have it backwards.
For UI left, the direction is going to equal to 1. UI right,
be -1, won't it?
yeah, UI right will be direction X is equal to -1, and then for, this probably should be +1, right? Yeah. We'll see in a minute. Yeah, I'm going to leave it like that for now.
In my head now.
Yep, so direction Z will be direction
lowercase
Z.
z.
Yep, will be equal to 1, and direction.
It will be plus equals, I think.
No, I don't know. We'll see in a minute. We'll see what happens. Yeah, so that one should be plus equals, and direction Z shall be
-1.
minus equals 1. Yeah. So
this is like so you've got X, Y, Z.
So we want these keys to be able to move the player around in the scene. That's basically what we're doing here. And I'll just quickly show you. You can go up here to the project settings and then the input map, and you can see that UI right, okay, is mapped to a key or a D-pad or whatever it's connected. So it's mapped to right, up, down.
It comes with a bunch of sensible defaults.
You can add your own if you want to add an action by name and then map keys to it. So this is so you can abstract the action away from the platform it's running on, because Godot lets you build apps for
multiple
Android,
platforms.
iOS, consoles, whatever. Okay, so that's done. We need to normalize the direction. So no matter what direction we're going in, we want it to go the same speed. So we're going to say direction equals direction.normalized.
Now, one thing that you will have to, if you do want to do any game dev, you are going to have to be okay-ish with 3D movement. It's not as like life or death as it's often implied in a lot of sort of like people, but you do have to be okay with mapping 3D movement and a little bit of 3D maths.
We're also going to make sure the thing moves at a useful speed, because we don't want it to, zoot ultimate distance too fast. So we're going to multiply direction by the move speed we've set up here, and also by the delta, because this is being called every physics tick.
The reason we're multiplying it by the delta is because otherwise, if the frame rate or the physics rate in this case was inconsistent, the movement speed would not be nice and smooth. You'd sort of be like jumping or teleporting or that, depending on what the time difference is. So we're basically just adding in how long has it been since the last update, so that way we get a nice smoother movement.
So games are all about tweaking. So in this case, I would like us to fall faster than we jump. So I've just done a little check for velocity here. So in this case, if we are not jumping, we fall, and we fall faster than we jump. So we move down faster than we move up, and that's all this if is doing.
There's a lot of like lying, I guess.
Lying. Straight up lying.
Lying's not the right word, but you've got to trick a lot of the way your brain works in game dev. You don't actually fall faster than you should in real life, but if you fall at a normal rate, it feels weird, so we tend to make you plummet down.
I'm going to apply some gravity now, so we're just going to fiddle with the velocity on the Y. So velocity.y is, add some gravity to it, but multiply it by the delta, so it doesn't add all the gravity at once. Otherwise, it would add 9.8 negative every single time it got hit, whereas we want to add a bit of 9.8 based on the frame rate that's going on.
The physics tick.
Yeah. So we want velocity.x equals direction.x, just so they're the same. And because velocity is a 3-part vector, we want to also do velocity.y is direction.z.
Z. Not Y.
Sorry, Z. Yeah.
Or else otherwise when you went up, you would
velocity
shoot
Z
upwards.
is direction Z. Okay. And now we want to actually make the player move. So you use this input to actually make it do something. So we're going to store it in the velocity, because the velocity started as zeros, and after this we're going to end up with an actual velocity that we want to keep using. So we're going to use a function called move and slide, which comes in as part of Godot. It basically stops the thing from hitting anything in the environment. So if it hits something, it will stop.
Pretty much every game engine, especially Godot, comes with a whole bunch of you don't want to have to think about it functions.
And you'll see here that I can
stuff.
actually command click this move and slide, and it tells me it moves the body along a vector. If the body collides with another, it will slide along the other body rather than stop. It's great, right?
It basically just means otherwise you don't have to do the calculations yourself for when you fix
Built-in
something.
documentation is great though. So we're going to pass velocity into that and pass a vector in telling it which way is up. That's pretty simple. So
the way up is up, Y.
Also, if we want to be able to jump, so we're going to add an ability to jump. So if is on floor, which is another built-in Godot function, you can see that by command clicking on it, is on floor, returns true if the body is on the floor. Only updates when calling move and slide. Pretty simple, right? This is just Godot's inbuilt awareness of its own physics engine.
Because physics maths can get hard very quickly.
So if is on floor and input is action pressed. I want to make a jump, so I'm going to leave that blank for a second, and I'm just going to go velocity dot y equals -10. So we want to jump, so that's what we're doing there.
10?
10, sorry, yes.
Yeah,
we want to go up,
not
sorry,
down.
you're not up, not down.
Right,
This is our inverse jump, yeah. We want to, so if we're on the floor and we push a button that is mapped to jump, we want to go up in the air. Currently we do not have an is action press for jump, so I'm just going to go into the project settings, input map, and go game jump. Click add. Game jump is added to the end. I'm going to add a key. Jump is going to be spacebar. So you can see here, spacebar. Whoops. I pushed another button. Aha. Game jump. Add key. Space. OK. Space is mapped to game jump. Now we can go is action pressed. Game jump. And it even auto completes it for me, which is pretty useful.
Very useful.
That's actually everything we need to do right now in the code for the player. So I'm going to save this player.gd, Command S, and go back into the environment. And then I'm going to click my player, and you'll see he has a little script attached to him. Down here, player.gd. I'm going to push Command R to run it. Absolutely nothing will happen because we haven't got a camera. That was deliberate. Trust me.
It is doing things under the hood.
I didn't forget that I'd not put a camera in the scene, not even slightly. So I'm going to add the camera to the environment by clicking the environment, clicking here, and then I'm going to add a camera.
Godot actually comes with a few sort of like pre-built cameras. It's got a pre-built AR camera.
I'm going to move it over here,
AR.
and you can see this like frustum thing, which is showing us where the camera's pointing, which is currently pointing over there. Click this little preview button. I'm going to rotate the camera to be something more useful. Yep, that's slightly more useful. I'm going to rotate it down a little bit.
Love it.
Okay, and now I'm going to run. Now we should have a view in our game. And we move the player around. Yep, look at that.
Look at that.
He moves. It's great.
Jump, hopefully.
Whoa, look at that.
Notice he jumps, he falls much quicker than the rate he moves at.
Yeah, that's pretty cool. But you'll notice the camera isn't following the player, which is slightly annoying in a video game. You often, if I go over here, he might, my keys are actually not mapped correctly, which is why I'm having trouble moving around.
I think you have equals when it should be a plus.
Oh, it's working good enough. It's fine. So if I go this way, right, it's not going to follow me, so I can jump off the world.
Whoa.
Camera didn't follow me though. So what I'm going to do is I'm going to go back to Godot, and I'm going to drag the camera onto the player. So now the camera is parented to the player, which means it'll follow around. This is a very crude camera follow. You could write a nice script so it follows you around like Mario 64 with the little cameraman, but
yeah, you normally have like a lerp as well, so you don't you're not hard following. You're
so now if I run it again, the camera
behind.
will move with the player, and I can do something useful. This is actually hard with these keys mapped like this, so I should probably fix that.
The keys.
Yeah.
Let's fix the keys.
Let's fix the keys. So we need
player.gd script.
Yeah, okay. Let's try to figure out what to fix.
Let's have a look. It's always the fun in live coding.
So
that should be a plus equals 1, I think.
You sure can?
Yeah, pretty sure.
Nope.
What's going on there?
It's just it's rotated, so.
Oh,
yeah. So we're going to go. That's UI up.
I'm with. Oh, right. Sorry.
That's
so
UI.
we're 90
down.
degrees relative to
That's
where we think
UI,
we are.
Yep. I think.
So our left is forward.
I think that's correct now.
Well, you got to. There's strings. You need the little. Yep. What's that thing called?
Yeah, look, okay, so now we can drive
What
around.
are those things called again? Quotation marks.
So this is all working properly.
There we go.
Now I can drive around, I can jump up that ramp. The ramp's probably slightly too easy if this was actually a video game, but it works. We're going to add some code now to make the goal work, okay? So kind of I can move that around, but it doesn't really...
It works!
It doesn't move very well, and it doesn't know that I scored a goal.
It's good enough for actual soccer.
It's good enough for actual soccer. So I'm going to go back into my environment.
They don't know when it's
They don't know. I'm going to go back into my environment and click on my ball, and I'm going to tick this little box that says can sleep and turn it off, because that means the ball will fall asleep if we don't move it, which means it won't respond to physical impulses. So now if I go and push that ball, it will actually respond much more pleasantly.
Sleep is just a way the game can.
So you see if I give it a gentle nudge, you'll see that it
It's a little hard with the camera.
Rolls nicely now instead of just flying forward, which is much better. What we're going to do now is going to add some code to make the goal know when it's hit a goal. But first I'm going to go into my main area here, which is this environment node. I'm going to add a script to it. And I'm just going to quickly write a script that lets us reset the game.
The reason you would want this is because often when you're tweaking values and basically getting the game feel right, it's really useful to be able to just reset the world without too much work. I'm
going to go is key pressed and just look for the key enter, so I'm not going to map a nice action here like I did last time. This is just brute forcing the enter key. And I'm going to get the tree and reload current scene.
So basically just telling that scene to redraw.
I'm going to run the game again, and you'll see now that if I move around and push enter, the game resets to where it was.
Look at that. Sweet. I love it.
Pretty useful. It's really useful to debug your game as well. So now we've got that in place, I'm going to quickly go into the goal. So on the upper platform, I'm going to add an area. So I'm going to move my scene so I can go here, and I'm going to click on that upper floor, and I'm going to add an area to that.
So what we're actually doing is we're not adding a goal to the goal as such. We're going to be adding a goal to the floor that it's on. But, you know, from the player's perspective,
and that area
they won't know.
Is here. Yep.
Just need to sort of place it roughly correct.
That's close enough for now. Yep. In the area, I'm going to add a collision shape to it. So I'm going to click the area and go collision shape. Quickly add a box to it. This box basically says what shape is the goal.
Let's stretch it out.
You can see it over there a little bit. I'm going to scale it a bit so it's, you know, a goal that the ball. So anytime the ball goes through this thing over here, we will score a goal. Very simple.
We may have made this a little too easy, but that's
probably
all right.
made this a little too easy. So
a little bit thinner. Come on.
A little bit thinner?
No, a little bit as in like this way.
Oh, right, I get you.
Because like you can just hit it anywhere. There we go. That's a bit
better?
closer.
Yeah, okay. That'll do. That's good enough.
We can spend a little bit more time making that accurate.
Yes, yes. Okay, so we're going to add a script to the game to now let us score a goal. So what I'm going to do is I'm going to click on this little area, and I'm going to go to the node tab over here. And you'll see this area emits a bunch of signals. Okay, so these signals are things that we can connect up to our code to make it do things, and we want to use the signal body entered. So because this node allows us to detect when something enters it, we're going to use body entered. So I'm going to click body entered. I'm going to click connect down here. It's going to ask me where I want it to connect to. I would like to connect it to the environment. So we're going to click connect, and it's going to add a nice on body entered for our area to the environment GD script which we made earlier. I'm going to delete pass, and inside this I'm going to go if body is rigid body, which means this can only be the player, we will print hooray, goal, into the terminal. We haven't got time to make a UI today, but this will print it into the console. I'm going to click save on that, and then I'm going to run the game. And you'll see the terminal is down here underneath this thing here where it says I have a FaceTime camera. So I'm going to move up here to the ball and try and push it through the goal. Whoop. And it says, hooray, goal, because it knows the ball has gone through. If I do it again, you'll see I can do it multiple times and it'll know the ball has gone through. That's pretty great. Hooray, goal. And that's pretty much our whole game. I'm just going to go quickly and make the power-up do something because, you know, power-ups should do something. So I'm going to click on our little cube here, which is our pickup. I'm going to add a script to it because, you know, everything needs a script. Inside that script, I'm going to say on process, so every single frame, please make the script rotate the cube. So we're going to say rotate X, deg to rad.
Process is called literally every frame, so that'll be running at probably about, what's your screen's frame rate? 120 hertz?
120, yeah.
So it'll be called 120 times a second, give or take.
Yeah, and rotate on the Y as well. I'm going to run that, and now our cube will rotate like a proper video game power-up. You could make the same open body entered signal send to that to pick it up as well. Now we're going to go quickly back to our slides and finish.
So, I mean, that was Godot. Hopefully you learnt something good out of it. Thank you for coming. We're in the chat right now. So do send us any questions, or you can tweet at us as well. We're also pretty loud on Twitter. Yeah,
Godot's amazing. You can export to Mac, Linux, iOS, Android, web, everything. Build a video game.
You name it.
Thanks.
Go have fun. Thanks.